Production of continuous electric current. In the topic electric charge, we learned about how electric charges are produced. But that type of electricity is called static electricity because the charges are static, they are stationary. But if you want electricity to do work or to perform a task, you need to make it move. So in this lesson, we are looking at the production of continuous electric current, where those charges now become a current. In continuous electric current, we're going to see how those charges are made to move, how those charges are made to produce current. The moment the charges move from one point to another, current is produced. So how do we make this current to be continuous? How do we make the production of current to be continuous? So electric current is the rate of flow of electric charge through a conductor. So the rate at which charges move through a conductor from one point to another is electric current. And it is measured in amperes. The unit of measuring electric current is ampere. For electric current to flow continuously, remember I said in the topic where we treated electric charge, that was static electricity, where the charges don't move. Now, in order for the charges to move, when charges move, current is produced. In order for us to be able to produce a continuous electric current, what must be done? Number one, we must have a source of electric energy. Number two, we must have a closed circuit. Number three, we must have conducting materials. So continuous electric current is a steady flow of electric charge through a conductor for a long period of time. So it is mainly produced by using cells. Remember in the lesson on electric circuit, I said a cell is like a single battery, while a battery is made up of more than one cell. So continuous electricity is produced by cells, it is produced by batteries, it is produced by generators, it is produced by dynamos. It is produced by solar generators. So sources of continuous electric current, we have a simple cell. A simple cell converts chemical energy into electrical energy. Now this is a diagram of a simple cell where we have electrodes inside an electrolyte that produces continuous electric current for some time. Part of a simple cell: zinc plate, copper plate, dilute acid or electrolyte, and then a container. So the zinc plate and the copper plate are the electrode. So the acid is the electrolyte. And the whole of this material is placed inside a container. So like we can see in this diagram. Working principle. Now zinc reacts to the acid and releases electrons. Electrons flow from zinc to copper through the external circuit. This flow of electron produces electric current. Disadvantage of a simple cell. So there are two disadvantages of a simple cell. Number one, polarization. And number two, local action. Polarization is the formation of hydrogen bubbles around the copper plate of a simple cell. The effect, it reduces current flow and it increases resistance. Prevention of polarization. Using a depolarizer such as manganese dioxide can prevent polarization. Local action. Local action is the wearing away of the zinc plate due to impurities in the zinc. As you continue to use the cell, the electrolyte will be eating up the zinc. Prevention of local action. Using pure zinc And then amalgamating zinc with mercury can prevent local action. So another way we can produce continuous electricity is by using a dry cell. A dry cell is an improved form of a simple cell in which the electrolyte is in paste form. Components of a dry cell: a zinc container, a carbon rod, electrolyte paste, manganese dioxide, and an insulating seal. The advantage of using a dry cell: it is portable, it is easy to use, it does not contain liquid, there's no liquid spillage. The uses of a dry cell: a dry cell can be used in a torchlight, in a radio, in clocks, and in remote controls. The accumulator, a storage battery, is another source of continuous electricity. An accumulator is a rechargeable cell used for storing electric energy. So this is a picture of an accumulator. Example, we have the lead acid accumulator. Uses: can be used in cars, in inverters, in power backup systems. Advantages: it can be recharged. An accumulator can be recharged. An accumulator supplies large current. Generator is another source of continuous electricity. A generator is a machine that converts mechanical energy into electrical energy. It works on the principle of electromagnetic induction. Types of generators: we have DC generators and we also have AC generators. Dynamo is another example of continuous electricity. A dynamo is a small generator that is used to produce direct current. Applications: it is sometimes used in bicycles and in small electrical devices. The difference between a primary and a secondary cell: a primary cell cannot be recharged, but a secondary cell can be recharged. An example of a primary cell is a simple cell, while a secondary cell is an accumulator. So a primary cell cannot be recharged, but a secondary cell can be recharged. So example of a primary cell is a dry cell. An example of a secondary cell is an accumulator. Conditions necessary for continuous current flow. For current to flow continuously, some conditions need to be met. Number one, the electric circuit must be closed. It must not be opened. Number two, there must be a source of EMF. There must be a source of energy or a source of voltage. Three, conductors must be properly connected. So for current to flow continuously, the circuit must be closed. There must be a source of EMF. There must be a source of power, and conductors must be connected properly. Remember, I said that for electric current to be continuous, one of the conditions is that there must be a source of EMF. So what is EMF? EMF is an electromotive force, or rather, electromotive force, which is EMF, is the energy that is supplied by a cell per unit charge. And the symbol is E, while the unit is volt. So the higher the EMF, the greater the ability to drive current. Applications of continuous electric current: it is used in lighting, it is used in charging of phones, operating radios, running electric fans, operating electronic devices. So safety precautions: avoid short circuit, do not connect terminals wrongly, keep batteries away from fire, avoid touching naked wires. Summary of the lesson: electric current is the flow of electric charge. Continuous current, steady flow of charge. Continuous current is steady flow of charge. Simple cell converts chemical energy to electrical energy. Polarization is a process where hydrogen bubbles reduce current. Local action is a process where zinc plates wears away. Dry cell are portable electrical source. Accumulator are rechargeable cell. Generator converts mechanical energy to electricity. Dynamo are small DC generators. After watching the video, answer these questions below. Question number 1, define electric current. Question number 2, what is continuous electric current? Question number 3, state 3 sources of continuous current. Number 4, explain polarization in simple cell. Number 5, differentiate between primary and secondary cells. Number 6, state 3 safety precautions when handling electric cells.